We're here at the CROI. We're winding up the CROI, and we do an annual visit with the Director of Clinical Virology, Romas Geleziunas, who's kind enough to give us a little bit of his time to kind of get up to speed with what your primary things are, the new things that are happening at Gilead. So if you will, just dive right in and give it to us.
Well, Fred, it's a pleasure to be back. This is, I think, our fourth visit now, so I look forward to these every year. So. All right, so last year when I stopped by, I told you about a monkey study that we had done with a class of compound called TLR7 agonist. And we had done an experiment where we took monkeys, we infected monkeys with SIV, not HIV, of course, the simian cousin, and we put them on antiretrovirals, suppressed them well, and then we dosed them with this TLR7 agonist. And we showed in this presentation last year that we caused plasma blipping, or transient plasma viremia, every time we dose. Well, there was a lead-in period, but doses 4 through 7 caused consistent blipping of plasma. So this was exciting to us in the field because we may have basically identified an agent that would activate virus persistently.
The shock and kill piece, this is the shock.
Exactly, the shock. Looks like we're activating virus, so maybe that's the story. And so this year, we presented a new story in collaboration with our colleagues at Beth Israel Deaconess Medical Center. And it's a second study. And this study, the aim was to actually test not the original TLR7 original one was also in the study, but to test the drug 9620, clinical candidate actually, that is actually now in clinical studies in HIV-infected persons and as well as in HBV-infected persons. So we wanted to see if the drug, per se, would be able to do what the other agent, the analog, did last year. And also, we dropped the doses because the doses are now more in line with what we are dosing in the clinic. Okay, so we repeat the study. We get these monkeys, SIV infect them, CART suppress them for 15 months. So we went hardcore here, made sure they were well suppressed. And started dosing these the 2 TLR7 agonists, last year's compound and the drug 9620. And again, see this phenomenon. After a few doses, we start to see the plasma blipping phenomenon. Okay, so that's quite interesting again. But this time what we did is we gave them more doses. We gave some monkeys 10 doses, other monkeys 19 doses every 2 weeks, exactly as we would plan to do in the clinic. And basically after that period of dosing, we stopped the antiretrovirals to see what would happen to the rebounding virus. And to our surprise, 2 monkeys after 4 months have still not rebounded, while all the other ones did. So we have this intriguing finding now of 2 animals that seem to be at least temporarily controlling their virus. Now, I have to caution you, this is a small monkey study. It was 9 animals dosed with drug, 2 with placebo, so we obviously have to repeat this in a bigger cohort of animals. Obviously, we need to find out if this happens in the clinic, but this is a nice study that tells us to maybe keep going with the TLR7 program and to see where it might take us. So anyway, so go ahead.
Is this drug unique, is there a cousin to it, or is there a sister drug in process, or is this separate? Is it
so we have a program, and we have basically been working with the 2 molecules. So 9620 is the drug candidate, and the other molecule is a sister, a very close relative to 9620 that we used in the study last year. So these are very close analogs of each other. So.
Okay. So where do you go next? So you're going to expand it and replicate it and
combine it, start combining this agent with other agents like antibodies and vaccines, so that might get interesting. And importantly, I did mention last year that we were planning a clinical study, and we are halfway through the clinical study. So we have tested, or are testing 3 doses of the drug 9620, the same one that was put into monkeys. And we're halfway through the second cohort, so we're going to see how it performs in people now, and to see whether essentially we get that blipping phenomenon. So that's the purpose of that study.
So I talked with people about how to combine agents to get to a undetectable and sustainable treatment. But so this you're doing already. I mean, you're not waiting until you've proven this out. You're already trying to combine it to get more longer sustainability. Is that?
Exactly. That would be the plan. So last year, when we saw that in that first monkey study, this blipping phenomenon, we immediately went forward and said, okay, what would make sense to combine this with? We thought antibodies would be a good way to combine it because antibodies will bind to the envelope of the virus on the surface of a cell that will have been hopefully pushed out by the TLR7 agonist. So TLR7 pushes out, puts envelope on the surface, the antibody now binds, and hopefully through some mechanism such as NK cells or phagocytes would then kill the infected cell. So we think that the TLR7 antibody combo makes good sense. And vaccines as well. TLR7 and vaccines make sense as well.
So does it matter that we don't know the action or the actor, or is that something you'll describe later, or kind of like?
And when you mean actor, you mean like what is the mechanism? How exactly is this thing working? I would say we can figure that out later. Right now, our goal, our mission is to, as you know, for many years, is to try to find a way to have people have sustained viral remission without antiretrovirals. So that's our mission. That's our number one goal. If we don't understand the mechanism fully, I don't think it's the end of the world. But we need to figure out if this works in people.
Would you feel comfortable if you got to a point where you would need boosters and that sort of thing down the line? Is that? I mean, we don't know what the cure is going to look like, or whether we can even call it a cure.
Exactly.
But it would be maybe a sustainable
viral remission.
Right? So how I don't think. I think we're already at the point where we're using drugs to at least, implant, and that we therefore don't have to bother with treatment very often. It's hard to distinguish the difference between that and maybe what we might call a sustainable viral suppression or quasi-cure, if you will.
You're absolutely right. I think what you're thinking of there is long-acting agents, right? An agent that you can implant or deliver once per quarter, maybe twice per year, for example. And you haven't cured yourself, but you have an agent or a series of agents that contain the virus, right? So that you're able to be healthy and well with those drugs. You're right. The difference between that scenario versus a scenario where you have a series of agents that you give occasionally and somehow help the immune system, for example, achieve the same role. You're not cured, but you are in remission. And both strategies involve repeated dosing of drugs.
The one is actually giving drug ongoing, it's sustainable release or sustained release or whatever they.
Right.
Yeah. As opposed to giving a dose and then not giving drug for a period of time and then expecting that it will last. Durable response.
But maybe under that scenario, you have to come back maybe once a year or twice a year to give some form of a boosting agent, like a vaccine, for example. In other words, you're never done. You just have to keep administering the agent to keep the immune system revved up and able to handle the virus.
And the other question, of course, is infectability with that person. That would be another. How likely is that? Much the way it is today with persons undetectable. They see that as a benefit because it reduces the community viral load, being undetectable and having unprotected sex, would then that maybe be something you could look at there as well.
I think that's a critical point. In other words, if we achieve some form of a remission in which a person is still viremic and potentially transmitting, we did not achieve our goal there.
Right.
We really need to achieve a goal of really undetectable virus so that the person is not transmitting their virus. So this is why the bar is so high. It's really complicated what we're trying to do, but we're trying hard. So.
But it's great that you're achieving what you had hoped for. And of course, we will keep on waiting and hoping.
Yeah, exactly.
That you're going down the right path.
Keep working, exactly. Yeah. Figure out this TLR7 story.
So you had another issue where you're trying to do some funding.
Yeah, we're very excited. This week, Monday actually, Gilead announced that we are starting a new grants program. And this is, I think it's a very exciting opportunity because these are going to be grants of approximately $2.5 million over 3 years that will be given to academics, nonprofits, and the purpose is to identify concepts that we'd like to test in translational studies, so small pilot human studies or animal studies where we need some help to figure out if we're on the right path or not. So I think this is a nice opportunity to figure a few things out much more quickly now since this funding is available and or will be available most likely by the early part of next year. And so we're very excited about that. I think this should invigorate the field further and just to make sure that we're trying to search for that cure.
Well, I don't know if you know the answer to this, but would you be obtaining or maintaining any royalties from that?
Yes, that's a great question, Fred. No, there are no strings attached with this. This is purely, again, to support academic research, and we're delighted to be able to do this because, and talked about this over the years that I've been visiting with you. No one company, no one group will find a cure by themselves. We've talked about this. You need a lot of collaborators, a lot of good people, good scientists working together to achieve this. So I think this is a way to add more funds and to basically have more people engage and test concepts together.
Well, I'm glad you're doing that, because we talked with Carl Diefenbach, and he's of the opinion that we're probably not going to get new funding or extra funding or more funding. Flat funding is where we're at. So when you can give back in this way,
I was going to say,
I mean, we have to ask the businesses and the partnerships, whatever can be developed. So great start. Maybe you're in a position now to say others should do the same, or maybe we should look to other industries. You know, it doesn't have to be pharma. You know, I mean, you're in the business, so it's probably more appropriate for you to do it than others. But it certainly would be appropriate for us to ask to give the funding, because, and I'm sure you're going to measure you're going to evaluate the proposals that someone has to use the funds to make sure that they're going to be used well, because I know that's what Carl is doing.
Exactly.
They have a very, you know, he says it's just we have to work smarter. We keep on working smarter.
So exactly, we're going to make sure that we fund proposals that are scientifically sound, right? Because that's what we want to do, and give them a little kick. And so you're right, you can view this as supplemental funding to the NIH and to AMFAR, for example, who are the major funders of cure research right now in America. And so Gilead will be supplementing that now. So.
Well, that's great. I appreciate you taking the time to do that. Is there anything else you wanted to contribute, or?
Just glad to be visiting with you.
Well, I'm glad you're here.
And thank you for having me.
I'm so glad you keep on doing this and letting us know about it too. And the community needs to know that you're in the business of you know, not benevolently, but obviously you're making money at what you do. But it is a generous thing to contribute some money back into the coffers, especially into maybe some new young researchers that could...
New ideas, exactly.
I've visited with 3 of them tonight, and they're all excited about what they're doing. And that's what we want. We want researchers, young researchers, come on board, get involved, and the best and the brightest, I guess, is what we're looking for, because this is a complicated disease.
Exactly right.
You can't miss that one when you when you look at it, when you go upstairs and you see some of the research that's going on. It's not easy. This is not for the faint of heart. This is for the bright and the smart.
You're absolutely right.
Yeah. Thank you so much again. I appreciate it. Yep.
Good.